Hello everyone, how are you doing? Today we are going to talk about a very important concept in programming called caching. In order to write an efficient program, you have to apply the caching concept. There are several algorithms present for caching like least recently used, least frequently used, most recently used, first in first out. So in this video, we are going to learn about LRU algorithm or least recently used algorithm with Python. Hi, this is Pulokesh. You are watching MTech Learner. So in order to understand the problem, let's see a simple Fibonacci series problem here. So I have just implemented a simple Fibonacci series here. Okay. So I'm just recursively calling the Fibonacci series. And after that, I'm just calling that function inside a for loop while I'm repeatedly execute that method. Okay, and I'm also calculating the execution time. Okay, that's the pretty simple thing here I'm doing. So let's just run it, and as you can see, I am calculating the result for each number. Now you can see what is the problem here. Now my problem is when I am at 3, I have already calculated for 2. Okay, so I have the value for 2, but still while I am at 3, I am calculating it again. Okay, same goes for 4. While I am at 4, I have already calculated the value for 3, right? So why should I calculate it repeatedly? I should consider the calculated value for 3 and I should calculate for 4 only. Okay, so that's the problem here, and this is not taking that much of time, as you can see. Okay, but if I increase the range little bit higher, let's make it 20. Okay, now you can see my execution time got increased. Okay, so and this execution time got increased because the computation is happening for each input. So what if we can store the calculated data temporarily in a location so that we can reuse it while it required, and that is possible by using caching. So what is caching? In a nutshell, the concept of caching revolves around utilizing programming techniques to store data in a temporary location instead of retrieving it from the source each time. Okay, so you got the idea about caching. Now let's understand what is LRU. So LRU stands for least recently used. Okay, so I have a diagram here. Let's see that and understand it. Okay, so here we have a cache which size is 3. So we can store maximum 3 computation value in memory. Now see, after storing 3 value, just I have computed some value here. So just I am putting it first A and then B and C. Okay. So after storing 3 value, if I have another value to store, in that case I have to kick someone out from the memory, and the question is which one I am going to kick out. So now LRU says that you can kick that value which has been least recently used. Okay, so here as you can see that after putting 3 value, I have used A recently, so it got used recently. So in this scenario, B is the value which is got used least recently used basically. Okay, so if I want to put another value like D, in that case B will be kicked out and D will be placed inside my cache. Okay, so that's the concept of LRU. Okay, so I hope you got the concept. So alright, let's implement this to our Fibonacci program. So the problem here was that we are calculating it repeatedly. Okay, so in order to implement LRU caching technique in Python, you just have to do two simple things. First, you have to import LRU cache from func tool. So this is module. From here I'll import LRU cache. Okay. And second thing, I am going to use a decorator which is called LRU, and where I'll pass an attribute called max size, and let's say it is 16. So what is this max size attribute means? So max size attribute defines the maximum number of entries before the cache start evicting old item. So by default max size is set to 128. If you set max size to none, then the cache will grow indefinitely and no entries will be ever evicted. So, and I would not suggest to do that, because in that case your system memory will be empty. I mean, after a certain point of time, if you are doing a heavy computation, in that case your system will be crashed. Basically there will be no memory left. Okay, so don't do that. So here I am just using max size is 16. So basically cache size will be 16 here. Okay. So now you don't have to do anything else. Just, okay, let me pin it here so that we can compare the both output. Okay. So let's run it. And now the magic thing happens. First of all, you have already seen that it took this many seconds to execute. Okay. Now you can see it took less than that. Okay, first of all. Second thing, what I was telling you, that while I am at 3, I should have the calculated value of 2. So that's why it is calculating for only 3, because till 2 it has the value. Okay, so it just consider that value. Let's go down a little bit here. Okay, so you can see the calculated value for 8 is 34. Okay, so while I am at 9, I am just considering the calculated value of 8, so which was 34, and I am just calculating for 9 only. Okay, I am not calculating it from the beginning. Okay, I have already the value of calculated value of 8, so I am just calculating for 9. So now you can understand that how much execution time can be improved, or how, I mean, by using this caching technique, your program can be optimized basically. Okay. So subsequently, caching can provide an application performance boost, as it is faster to access data from the temporary location than it is to fetch the data from the source system. So such as from database, web server. Okay. So I think you got the idea, and I hope this is helpful to you.